Welcome to the Exoplanet Revolution, where we explore the fascinating world of exoplanets, planets beyond our solar system. In this video, we will take you on a journey through the history of exoplanet discovery, the latest discoveries, and what they mean for our understanding of the universe. A montage of images of exoplanets, telescopes, and scientists at work. For centuries, humans have looked up at the night sky and wondered if there were other worlds like ours out there. It wasn't until the 1990s that we finally had the technology to detect planets beyond our solar system. A timeline of exoplanet discoveries starting with the first confirmed exoplanet in 1995. Since then, the pace of discovery has been staggering. We now know of thousands of exoplanets, and the number is growing every day. A graph showing the exponential increase in exoplanet discoveries over time. But why are exoplanets so important? Well, they offer us a glimpse into the diversity of planetary systems in the universe. They challenge our assumptions about how planets form and evolve, and they may even hold the key to finding life beyond Earth. Images of different types of exoplanets, such as hot Jupiters, super-Earths, and Earth-like planets. So join us as we embark on a journey to discover new worlds beyond our solar system. The exoplanet revolution starts now. So how do we detect exoplanets? Well, it's not easy. Exoplanets are incredibly far away, and they don't emit their own light. Instead, we have to rely on indirect methods to detect them. Diagrams showing the different methods of exoplanet detection, such as the transit method and the radial velocity method. One of the most common methods is the transit method. This involves looking for a dip in the brightness of a star as a planet passes in front of it. By measuring the size and timing of these dips, we can determine the size and orbit of the planet. An animation showing a planet passing in front of a star and causing a dip in brightness. Another method is the radial velocity method. This involves looking for tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. By measuring the size and timing of these wobbles, we can determine the mass and orbit of the planet. An animation showing a star wobbling as a planet orbits around it. There are also other methods, such as the direct imaging method, which involves taking a picture of an exoplanet directly, and the microlensing method, which involves looking for a temporary brightening of a star caused by the gravitational lensing of a planet. Images and animations of the different exoplanet detection methods. Each method has its own strengths and weaknesses, and scientists often use multiple methods to confirm the existence of an exoplanet. A chart showing the number of exoplanets discovered by each detection method. So there you have it, the incredible methods we use to detect exoplanets. But the real excitement comes from what we can learn from these discoveries. Images of scientists analyzing data and studying exoplanets. In the next segment, we'll explore some of the incredible discoveries that have been made so far. Thanks to the incredible technology and methods we use to detect exoplanets, we've made some truly amazing discoveries. Let's take a look at some of the most exciting ones. Images and animations of exoplanets and their characteristics. First up, we've discovered a wide variety of exoplanets. From massive gas giants to rocky super-Earths to Earth-like planets in the habitable zone of their star, we found a huge range of planetary systems. But perhaps the most exciting discovery is the number of potentially habitable exoplanets we've found. These are planets that are in the habitable zone of their star, where conditions may be just right for liquid water and the possibility of life. Images of potentially habitable exoplanets and their habitable zones. Another incredible discovery is the diversity of planetary systems. We found planets orbiting binary stars, planets with highly eccentric orbits, and even planets in star clusters. Images and animations of different types of planetary systems. But perhaps the most surprising discovery is the prevalence of exoplanets. We now know that most stars in our galaxy have at least one planet, and that there may be billions of Earth-like planets in our galaxy alone. Images and animations showing the prevalence of exoplanets in our galaxy. These discoveries have revolutionized our understanding of the universe and our place in it. They've challenged our assumptions about how planets form and evolve, and they've given us hope that we may one day find life beyond Earth. Images of scientists studying exoplanet data and analyzing their findings. In the next segment, we'll explore some of the big questions that exoplanet research is helping us answer. Exoplanet research is helping us answer some of the biggest questions in astronomy and astrobiology. Let's take a look at some of these questions. First up, how do planets form? By studying exoplanets, we've learned that planets can form in a variety of ways, from the accretion of gas and dust to the gravitational collapse of a gas cloud. Images and animations of different planetary formation scenarios. We've also learned that planets can migrate from their original orbits, which can have a big impact on the evolution of a planetary system. Images and animations of planetary migration. Another big question is, how common is life in the universe? By studying potentially habitable exoplanets, we're getting closer to answering this question. We're looking for signs of biosignatures, chemical or physical features that could indicate the presence of life. Images and animations of potentially habitable exoplanets and biosignatures. We're also studying the atmospheres of exoplanets to learn more about their composition and whether they could support life. Images and animations of exoplanet atmospheres. Another big question is, how do planetary systems evolve over time? By studying the diversity of exoplanetary systems, we're learning more about the different factors that can impact the evolution of a planetary system, such as gravitational interactions with other planets or stars. Images and animations of different types of planetary systems and their evolution. Finally, exoplanet research is helping us answer the ultimate question: are we alone in the universe? By studying potentially habitable exoplanets and searching for biosignatures, we're getting closer to finding an answer. Images and animations of scientists searching for signs of life beyond Earth. These are just a few of the big questions that exoplanet research is helping us answer. As we continue to discover new worlds beyond our solar system, we're sure to uncover even more mysteries of the universe. In a final segment, we'll explore what the future holds for exoplanet research. The future of exoplanet research is incredibly exciting. Let's take a look at what's in store. Images and animations of telescopes and future exoplanet missions. First up, we have a new generation of telescopes that will revolutionize exoplanet research. The James Webb Space Telescope, set to launch in 2021, will be able to study the atmospheres of exoplanets in unprecedented detail. Images and animations of the James Webb Space Telescope. The Transiting Exoplanet Survey Satellite TESS, launched in 2018, is already discovering new exoplanets at an incredible rate. Images and animations of the TESS satellite. And the European Space Agency's Pluto mission, set to launch in 2026, will search for Earth-like planets around nearby stars. Images and animations of the Pluto mission. But it's not just space telescopes that are pushing the boundaries of exoplanet research. Ground-based telescopes, such as the Extremely Large Telescope and the 30-meter telescope, will also play a key role in discovering and studying exoplanets. Images and animations of ground-based telescopes. Another exciting development is the search for biosignatures, signs of life beyond Earth. The upcoming LUVOIR and HAB-X missions will be able to study exoplanet atmospheres in even greater detail, looking for the chemical fingerprints of life. Images and animations of the LUVOIR and HAB-X missions. And finally, we have the possibility of interstellar travel. While still in the realm of science fiction, the discovery of exoplanets has given us hope that one day we may be able to explore these worlds in person. Images and animations of interstellar travel. The future of exoplanet research is incredibly bright. With new telescopes, missions, and technologies, we're sure to make even more incredible discoveries in the years to come. And with each new discovery, we'll gain a better understanding of the universe and our place in it. Thank you for joining us on this journey through the exoplanet revolution. A final montage of images of exoplanets, telescopes, and scientists at work.